Hi, chemistry students. I'm gonna be going through this PowerPoint on units, conversions, density, and percent error. You should be on the notes document that is associated with this. Actually, for this one, there are two that I'm going to post that you need to take notes on, but those details will be in your assignment. So, real quick, I just want to mention our learning intentions and success criteria. For units and conversions, by the end, you should understand the different units of measure and how they're related to making scientific measurements easier. You should be able to use those SI prefixes to explain relationships between units. You should be able to set up a T-chart to make mathematical conversions, and you should be able to perform successful conversions calculations. Okay, so talking about why units are important, we're just going to bring this example in of the Mars rover. So Mars rover cost $193 million to make. That's really, really ridiculously expensive. In 1999, it went up in a huge ball of flames and it crashed on the surface of Mars. So that's $193 million wasted. And when that was investigated, it was reported that it burned up in the Martian atmosphere because those engineers failed to convert some units from English units to metric units. So you may or may not be aware of this, but in science we do use the metric system. We use the metric system because it is much, much easier to do conversions between units in the metric system, and it's fairly universal. In fact, there are only 3 countries in the entire world, Burma, Liberia, and us, the US, that have not adopted the international system of units, SI system, or metric system as it is colloquially called. So we are one of 3 countries total that don't use the metric system. Everybody else in the world uses it, and it's super easy to do conversions with. It's a lot easier than the traditional system that we use is. But the problem is that since you haven't used that system since birth, it's going to seem foreign to you and it's going to be a little clunky to get used to. But I promise you guys, once you start using it, it's going to become like second nature. So let's just talk about what the base units are for these. Each thing on this list, each unit has a particular metric unit. That's its base unit. So for time, we measure time in the metric system in seconds, which shouldn't be that foreign to you. We all use seconds. For length, we use meters. You're probably used to using yards or miles or something like that, but we use meters. For mass, we're going to use grams, not pounds or ounces or anything like that. For volume, we're going to use liters. For temperature, we're going to use Kelvin or Celsius. That's the caveat there. Sometimes it's Celsius, but the base metric unit is going to be in Kelvin. For amount of a substance, now that is different than mass, and I'll explain why later, but for amount, we are going to use moles, and for density, we're going to use grams per milliliter. There are other ways to measure density within the metric system, but this is the base way that we usually do it. This chart is in your notes. This chart is extremely important, extremely, extremely, extremely important to you. You need to understand that when you use this chart, this space right here is your base unit. So I want you in your notes on this chart right now to write base unit here, because this is variable. We could be talking about seconds here, we could be talking about grams here, we could be talking about liters, we could be talking about moles, we could be talking about any base units. Any of those could go in this section. And as you move up or down, that base unit gets a prefix. So let's say we're using grams as our base unit. Let's fill in the little g there, because this is grams. That's how you're going to recognize grams if you see it. If we're up here now, then it becomes kilograms, megagrams, gigagrams. And if we move down, we have decigrams, centigrams, milligrams, micrograms, nanograms. So as long as you identify your base unit, that's going to change what you're talking about. Now, let's say that we were talking about liters here. Then it becomes kiloliters, deciliters, centiliters, milliliters, etc., etc. I just need you to know that using this chart. Now, this over here, this entire column is very, very, very important to you because it's going to allow you to do conversion. So let's go back to grams. Let's say that we're talking about grams, and this here is 1 gram. Well, 1 kilogram is equivalent to 1,000 grams. 1 megagram is equivalent to 1,000,000 grams. 1 gigagram is equivalent to 1,000,000,000 grams. 1 decigram is 0.1 grams. 1 centigram is 0.01 grams, etc., etc. So those numbers are going to let you do conversions later. And this here, this is the power of 10 equivalent to this number. So really these two columns are the same thing. It just allows you to write it easily in scientific notation. Okay, so let's move on. How are we going to switch from one to another? We're going to use conversion factors, or two values that are equivalent that are used for two reasons. You're going to either use them to cancel a unit out or introduce another unit. Conversion factors can be flipped based on your need. So, for example, I want to talk about the relationship between milliliters and liters. 1,000 milliliters and 1 liter is the same amount of material. It's the same thing. So this is a conversion factor. This 1,000 milliliters equals 1 liter. That is your conversion factor here. Okay? So you can write those. You can write that either way. You could write it on the way on the left. When you're setting up a math problem, you could put 1,000 milliliters over 1 liter, or you could put 1 liter over 1,000 milliliters. Now, which one you do depends on your problem, and it does matter. They're not interchangeable. It depends on what unit you're going for and what unit you're starting with. Okay? So let's say I wanted to know how many meters are in 48 kilometers. So as soon as you see this number given to you, since that number is given to you, that becomes your given number. And in your T-chart that you're seeing right here, this is a T-chart, you're all going to need to know how to use it. Your given number, that's what this is going to go in the upper left-hand corner. So you're going to write 48 kilometers. That is the abbreviation for kilometers. And yes, you absolutely do need to put your units here. Units are super, super important because you're not going to know if you're doing the problem right unless your units cancel out. And I can tell you right now, 99% of the time, I see students trying not to do this. They're just like, whatever, I don't need to write units. I'll remember. No, you won't. You may remember in these easy problems, but when they become 3, 4, 5, 6, 7 steps long, you're not going to remember and you're going to confuse yourself. So take my advice, write your units. Below your given number, it's a placeholder 1. That 1 is there specifically so that you don't try to write something else there. Please put your placeholder 1 in because the placeholder 1 always, always, always goes there. Now, we look back at the problem. Our problem's asking how many meters. So meters is going to go here. And since we are trying to get rid of kilometers, we're getting rid of this km, kilometers has to go there because when you multiply this out, those are going to go away. So you may be asking yourself, okay, well, what goes there? What goes in this blank space? Well, now we need to know what our conversion factor is. And let me just go back for a second to our previous slide. You remember how these were conversion factors over here? Well, the same thing exists for every single metric. So if you look at your chart above, I'm not going to go all the way back to it, but if you look at that chart, you will find out that the prefix kilo means 1,000. So if you look at your chart, in every 1 kilometer, because that's your bigger unit, for every one of your bigger unit, in this case kilometers, because of that prefix kilo, you should know that there's 1,000 regular meters in 1 kilometer. And so now we multiply straight across. We're going to multiply top straight across, and we're going to multiply bottom straight across, okay? And that's going to give us 48 times 1,000. We're going to go, all right, well, 48, 1, 2, 3. We have kilometers and meters over here. So I'm going to put them in parentheses. And then we have 1 times 1, which is 1 kilometer on the bottom. And then we reduce. You'll notice that this and this cancel out. Those go away. Remember what I said about canceling out units? And you are left with 48,000 meters. Because that 1, anything divided by 1 is itself. Okay? So that is how you are going to do that problem. So let me just get rid of that for a second. So at this point, there should be some practice problems. I would absolutely like you to try those on your own, and I will talk about what the answers are when I see you next. Now we have temperature conversion and density. So we're gonna have to be able to convert temperature and density as well. And temperature, those units are related to each other differently than other metric units, because we're not talking about giga Celsius degrees or giga Kelvin degrees or anything like that. We're talking about how is Celsius related to Kelvin, and they're two completely separate units. Okay? So if you have a degree in Celsius and you want to know how many degrees Kelvin that is, you're going to add 273. And if you have a degree in Kelvin and you want to know how many degrees Celsius that is, you're going to subtract 273. It's super easy. Barely an inconvenience. Should not be very hard for you at all. Your density formula is going to be density equals mass divided by volume. Again, not a difficult formula to use. Super user-friendly.